Alrighty, let's go ahead and dive in. So thanks everyone for joining this week's office hours. We have a couple of things I want to share, and then I'm going to actually pass it off to um, the engineering team. Last week we talked about having some special topics, and we're going to be starting off with memory today. Before we dive into that, we have a couple blog posts that I just want to raise for all of you. I'll go ahead and share my screen. I'm not sure if this was called out last time. It might have, but we do have a blog post now for kind of what's coming next for the summer fall roadmap. We've already kind of covered in this group those main items, so I'm not going to dwell on that too much. But perhaps even more exciting is we've been talking about our agent framework for a while now, and we now have a blog post where we kind of talk about what's now available today, both in C# and in Python. And we also kind of talk about our plans moving forward on how we want to continue to improve our agent framework. So definitely give this a read. I'll go ahead and paste this in our chat. And I know the plan is for next week, we'll do a deep dive on um, multi-agents within Semantic Kernel. But today, let's go ahead and dive into the memory topic. Um, Wesley, you're on point for that, right?
Sure, yeah. Let me share my screen. So yeah, can you see my my PowerPoint slide?
We can.
Perfect. So so Edward, Dimitro, and I have been working on revamping our memory storage scenario for the last few weeks, well, months, I suppose. We've come up with a new abstraction layer that addresses a whole bunch of issues that was there with the previous memory store implementation. We're calling the new stack or the new implementation vector stores. This is more in keeping with what other SDKs are doing as well. And it doesn't kind of have any opinion about how you want to use a vector store. It's really just about storing vectors. But some of the main things that we wanted to address was the current memory store implementations. Every implementation has its own opinion about how to store the data. And we have a fixed scheme, or we have a fixed data model as well in the system that has fixed fields. So you can't really have your own data model. You can't come with your own database that already has data that has a different schema to the one that we support, which is obviously very limiting for people who have databases already that they just want to add a vector store to and start querying or contribute to. So we've tried to address that by allowing you to have whatever schema you want and data model that you want with that as well, within limit, of course. We unfortunately we can't support every single combination, but there are break glass scenarios as well, or we do support break glass around that as well. We also one of the features of the current memory store implementations is that it has a goal of abstracting differences between the different databases. And we still have that goal, but in the memory store implementations, that goal was perhaps taken a little bit too far in some cases, where it would do a lot of opinionated behaviors in the implementations in order to achieve that abstractions. This means, like, for example, for Azure AI Search, it would strip out certain characters from collection names and key names before going to the database. So the values that you're passing to the abstraction isn't necessarily the values that end up in the database. This makes it quite tricky if you want to use an existing data set, or if you want to control the schema quite closely, since you don't necessarily have the abilities to stop these behaviors. For the new vector store implementations, we're making everything like that configurable, where we support it. And the goal of abstracting differences is still there, but we also have this mixed goal of really exposing the capabilities of each of the vector stores. In the memory store implementations, we supported search, vector search, and there was no filtering capabilities. So you couldn't say, well, I want to search this vector store, but I only want to search a subset of records that have field X equal to value Y. This is so you could only search essentially everything inside of a single collection. This obviously has implications in terms of scale, which is not great. It also makes certain scenarios really, really hard, where you want to maybe limit the set of records to a subset based on security information. None of these scenarios were easy to achieve. With the vector store implementation, we intend to support pre-filtering on searches. I have to call out those searches still in progress. It is not released yet, and actually, we just released actually about an hour ago both the .NET and the Python versions of the vector store implementations, but not including the search aspect. That's still in progress. Let me keep going. So which brings me to the current state. What we have is support for listing, creating, deleting, and checking if they exist on collections. We've got record upsert get delete plus batch operations. And for Python, we also support using container formats like pandas data frames. In terms of databases, the vector store implementations that we've created so far is Azure Airsearch, Quadrant, Redis using JSON and Redis using hashes, as well as a volatile in-memory version that it doesn't have any backing storage. It's something we've created inside of Semantic Kernel. And we support these for .NET and Python, and we also have a Pinecone implementation for .NET. We're working on adding MongoDB using Cosmos DB at the moment, and Azure Cosmos DB NoSQL will follow shortly after, and there's obviously a lot more coming over time as well. And then also vector search with pre-filtering. Did I miss anything, Edward?
No, I think this is a good write-up, and indeed all of the existing memory stores that we support, I expect we will port them over to the new model in the coming weeks.
Yep. So then, quick example in .NET, we're taking a model-first approach, which should be familiar to anyone using other .NET systems. So in this example, there's a model glossary defined on the left. Sorry, glossary model defined on the left, where each field is annotated with attributes to indicate the purpose of that field. So, for example, the key here is annotated with vector store record key attribute, the term and definition with data attributes, and the embedding field is decorated with a vector attribute. The 1536 is essentially the number of dimensions that this vector can have. There's also other properties that you can supply to these attributes that control other aspects. For example, you can supply what indexing type you want to use for the vector and what distance function you want to use when searching the vector. There's also various things you can set on the data properties, like whether it should be filterable and so on, because when creating an index, which kind of goes with when you create a collection, for many databases, you need to specify at that time which fields need to be indexed for filtering, and you need to specify the size of the dimension for the vector field, you need to specify the index type that you want to use and the distance function, etc. So, by the way, we are working on some documentation around this, so we'll have a lot of that ready pretty soon. So this is just a preview of what's possible, and on the right hand side you can see that the usage scenario here is just you've got a vector store instance, which would be you would have, for example, one for each database implementation that we support, and on that you can ask for a collection. You have to pass in what type of key and what type of record you are using in this case. In this case, this example is essentially that I created. I was using Quadrant. Quadrant supports ulong and GUID only for keys, so hence the key on the data type is a ulong, and here it's also specified as a ulong, and then the record is glossary. Then you specify the name of the collection. Then you can say, hey, I want to create this collection. If it doesn't exist, it'll go and create the indexes in Quadrant as well for that. And then you can just upsert your glossary object, and it'll map it to the Quadrant storage type and so on. Let me keep going, and we'll show you a Python example as well that Edward can talk through.
Yeah, so the idea is that it's very, very similar to the .NET one, except that we use annotations instead of the format that .NET uses. So I've created the same model basically here for the glossary. In this case, I did it with a standard Python data class, and I'll show in a second the different ways you can create these. Same setup with key field, data fields, and then the vector field. Also, the dimensions is in there, and like Wesley said, you can add other attributes as well. And then over on the right, you can see kind of the same flow of creating a collection, getting a collection from a store, then asking it to create the collection if it doesn't exist, and then doing an upsert with a record of the class you see on the left.
Awesome, thanks, Edward. Any questions before we dive into some demos? Okay, I will keep going then. So I'm going to show a quick demo here. This is actually this is at the moment in our repo. So under samples, concepts, memory, I've got 3 samples here for the .NET side. A very simple data ingestion example, a multi-store data ingestion example, and one that uses a custom mapper, which is a little bit more complex. But I'll go through the simple and the multi-store one very quickly here. So the simple one is using Quadrant, and just in terms of infra, this is just using a fixture here that is spinning up a Quadrant Docker container locally on my machine before connecting to it. So, so first thing here is I'm creating a Azure OpenAI text embedding generation service, which is
sorry, I was like, can you zoom in a little bit?
Oh, sure. Yeah, sorry. Yeah. Thanks for that. How's that? Is that better?
Yep.
Oh, yeah, I think that's good. Yeah, thank you.
Okay. So I'm creating a Azure OpenAI text embedding generation service, which is of course part of the Semantic Kernel as well. And then this is just initializing the Docker container, but here I am creating a Quadrant vector store and passing a Quadrant client that's pointing at local host. Then I'm basically getting the collection that I was talking about using ulong and glossary. Glossary is defined down here with ulong as with the key as ulong. And then I'm creating it if it does not exist. So next step here is creating glossary entries. So I've just got a little method here that creates various glossary entries. Then Then I'm taking all of those glossary entries and generating an embedding for each of them, and just updating the definition embedding field with the result of that. The input is the definition field, and the output is the embedding field value. And then I'm doing a upsert async for each of those, waiting for it to complete, getting the keys back, and then I'm actually getting the first one that was upserted, just grabbing its key, getting an async, getting async on it, and I'm asking to include vectors. Let me just step through that very quickly and show how it runs. I'll just do a debug. So here I haven't upserted yet, but if we go to my quadrant localhost here, I can see the SK glossary has been created. This is a brand new Docker container that just was created, spun up just there, and I've created the collection here using create collection if not exists async, and you can see here various settings and configurations that I've that's part of the schema. So then let me upsert the records, and if we refresh here, we'll see. Okay, now we have our definitions in here plus our vectors, and then we can retrieve that as well here using get async, and we get our vector back as well in this case. So I'll show a little bit more an example that's a little bit more complex as well. This one is the multi-store example. It's just showing how, well, you'll remember that I was mentioning earlier that there are differences between the different databases, certainly around what keys they support and so on. And instead of trying to hide that too much, to the extent that we have to do really weird things internally in the abstraction that you may not like or want to have done, we're trying to sort of simply make it easy to deal with the differences without being impacted too much. Ultimately, the biggest difference is going to be the key type. So in this case, I have an example that is using Redis quadrant and volatile. It can run against any of these three. And the main difference between these is Redis supports string keys only, quadrant supports ulong and GUID, and volatile, it can do anything. It's really a dictionary inside. So here what it's doing is, and actually it's in this case it's using dependency injection as well. It's using kernel builder here as a dependency injection container, but you can also use service collection. So it's certainly possible. And here it's adding the Azure OpenAI text image generation to the kernel builder. There's also helpers that we've added to kernel builder and service collections that allows you to just add these vector stores very easily to register them with the DI container. So here it's just doing, if it's Redis, it's adding the Redis one, otherwise the quadrant one, otherwise the volatile one. And I've got a data ingester class that is just doing all of the work, and I'm registering that here as well. And then I'm building the kernel, and I'm requesting my data ingester from the service collection. So, and then finally, where the differentiation comes in for Redis and volatile, I am using a little key generator that basically produces strings. It uses a GUID generator and it turns it into a string. And then for quadrant, I'm just generating a GUID. And this is really for creating new records. For each new record, it's going to create a new GUID. In the case of these two, it's a string. In the case of quadrant, it's going to be a GUID. And this is, just go to this method here. So here's the method. It's taking data ingester and then this function that generates the unique key that is generic. And then on the data ingester, I'm calling import with my unique key generator, and I'm getting the first upserted key, again, very similar to the other example. And going to look at the data ingester here and see that this takes the text embedding generation services input and the vector store. This would have been created by the dependency injection container automatically, and these would have been injected there automatically. And in the case of import, again, it's generic. That takes a T key and the unique key generator, and in this case, it's creating my glossary entries using that key generator. It's creating the collection if it doesn't exist. It's getting a collection using that T key, and glossary is in this case is also generic. So the key of glossary can be either a ulong or a GUID, or it could be a string. It doesn't really matter. And then where I'm generating the text embedding, or doing the text embedding, and I'm doing upserts, and it's very similar to the simple example in this case. And then getting the item, again, T key is generic, and it just calls get async with that value. So yeah, that's a very quick example. Any questions before I hand over to Edward to show off some of the Python side of things?
Yeah, Wesley, this is Jeevan
Sure.
here. I do have a quick question, right? So in the new models, like for example, text embedding, 3 large and small, right, where you can kind of control the dimension, right? How is that information being passed on, to the call? Because if you look at your registration, right, for the add text embedding generation, that is not a part of that, and nor is it, a part of the text embedding, that embed call, right, where you're passing in the dot definition, right? So how's that information, or how's that configuration possible, right?
Yeah, that's something we'll have to look into. It's not really the focus of what we've been doing with the vector store implementations, but it's definitely a gap that we have to address. I believe at the moment we're just defaulting to 1536 for the for the Azure OpenAI text embedding generation. I think on the Python side, there is a parameter, but we have to do something about it on the .NET side.
Yeah, it'd be nice if that dot, the text generation or the embedding generation service, right? Just like for inferencing, you have the options, right? Where you can pass the temperature, right? It'll be nice to kind of have something similar on the embedding side, so that it's extensible and it's configurable.
Yeah, absolutely, agreed. Yeah, we definitely need to look at that soon.
I did do something like that in Python, so I can show that.
Any other questions? Okay, well, over to you, Edward.
Yeah. So on the Python side, we like we said, we did something very similar, except that we have some more variations of different types of models. It's not sharing. And everybody's no.
It seems to stop sharing immediately after it tries to start.
Quite strange.
If you want to restart your Teams or something, we can hold on for a sec.
Yeah, I'll be back in a sec.
Any other questions while we wait? Any feedback or concerns?
Yeah, so Wesley, if you're probably, kind of going back to my earlier question, is that
sure.
revisiting the, the embedding endpoint or the text generation, an I embedding generation service, right? And that interface, is that a part of your roadmap?
Yeah, so I'll maybe, Matthew, I don't know if you have any kind of thoughts around the embedding generation service side of things. I don't have as much context maybe on that side.
Yeah, so on the text embedding service, that is one of the P0s for Ignite before we kind of go live. It's currently still experimental. We had someone from the community actually do a good job of creating a PR on us on how to improve it and actually created a draft PR. So we are working on getting that staffed. In fact, someone might be working on it right now so that we can update it and make it frankly look more like the iChat completion interface. So that, yeah, what you're wanting should land in the next month or so.
Okay, thanks, Matthew. And as just a follow-up, is there somewhere we can kind of follow the progress, or maybe at least kind of look at the design, how it's kind of shaping out to be, Matthew?
Yeah, I'll pull up the old PR for the ADR and I'll also share the issue that we're using to track this.
Okay, thank you.
Okay, cool.
All right, I'm back. We should see my screen now.
Yep, we can see it. Thank you.
Great. So on the Python side, like we said, we have a very similar setup. So the main differences are that we have a couple different ways you can create your models because we wanted to enable the kind of richness of the Python ecosystem. So the first one that we see here, and these are all samples that are in the repo in the samples concepts memory. So the first one is with just a regular data class. Here you just define it as any data class except with the annotations. And in this case, I'm adding some additional information to this data field, this content field, where I tell it has an embedding, and that embedding is called vector, and then it checks that this field actually exists. The second one uses Pydantic based models, so you can have a very similar looking class, except that it's using Pydantic under the cover. So if your application is using Pydantic, then this is quite convenient to be able to just put the decorator on there, and then you're off and running. We also want to make sure that if you have other annotations from Pydantic here as well, so like the Pydantic field, that still works even with these annotations that we add. Of course, a regular Python class also works. So in this case, I'm adding the same annotations to the init parameters, and those get picked up and used to build up the definition. And then finally, we have what we call the container mode, which you can set up like this. So you now specify your field directly. So you just tell it vector, key, and content with the proper field types. Set container mode to true, and this is optional, so you can also use it without that. And then add some method to tell it how it should create records. This is just to show that all of these will result in the exact same model, and so you can use these interchangeably between applications with the same vector store behind it. So let's look at the actual vector stores. So in this second example, which is called new memory, so we'll probably change that name at some point because it should be new in a couple of weeks. Here we have two similar models, and one of the things that we're doing here, and this is coming back to one of the questions that was raised, is we're using kind of a similar setup that we use with the execution settings in functions, where you can supply a dict with the service name and then the prompt execution settings for that service. And here you can specify all of the details that you want to set for your embedding. So when you call the special util that are created, then it will use these settings to look at this service and then create the embedding. And with this and the regular AI service selector that we use in the kernel functions as well, it means you can control exactly which model it will use for which fields and with what settings. So you can have different embedding models and use different settings for those models so that you can really create the embedding exactly how you want them. Then here I'm defining a couple of different stores, and in the code I'm calling one of them based on this parameter. So Azure AI Search Collection. So in this case, I don't have to supply anything. It's going to pick the connection string, the endpoint, and the key, and the index name from my environment variables. This Redis model will also go to the environment settings for the location. And here you can see that we have a Redis JSON and a Redis hasset. Quadrant will do the same, and the one thing about Quadrant is that it can run in memory as well, so you can basically have a non-persistent quadrant. So that is the default if you create it without any environment settings or any supplied info. And then the volatile collection, where you just tell it, this is my data model type, and this is the name of the collection, and then you're off and running. So the actual work, I'm adding the service here, so the text embedding service with text embedding pretty small. I'm opening up a connection to the store, asking it to create the collection if it doesn't exist. Then I'm creating two models with the type of the model, so it just has content and the ID in this case. Then we created this util class, vectors or record utils. You pass in the kernel, and then you just ask it to add vectors to records. So you pass in either a single record or multiple records as a list, as well as the data model type or the model definition. And then it will use the info it has from both this field where it says this is the embedding that you need to use. This is the field where the embedding is, as well as these embedding settings. You create the actual embeddings. Once that has done, then we can upsert, get, and then look at the results. So that's kind of the similar example that Wesley showed for .NET. One more sample that we added here is for pandas, because a lot of the Python community is obviously working much more on like the data engineering stuff, so they're very used to working with these kinds of in-memory columnar store type of things. So we wanted to support that as well. So here we create our definition with the container mode set and the same fields, as well as this to tell it how to create the data structure after it receives a result. Here I'm just creating two records as dicts in a list, and then passing that to data frame, calling add vector to records. That works. Adds the vector, the embeddings to those vectors as columns in the pandas data frame, and then I can just call upsert batch and get a record back, and that all works well. I want to add one more example. I haven't pushed this into the repo yet, but I deployed one of the sample indexes in Azure AI Search, which is called the hotel sample index, or the hotel index, hotel sample. And I was able to create this model in order to communicate with that. So it has an ID, a hotel name, a description, and then I add a description vector, a description in French, and also a vector for that. And then category tags, parking, last renovation date, rating, location, address, rooms. And the nice thing is that this was able to fully take the a record from that index, put it into this class, and then I have a local class that has all of that information, and I can just work with that. So just to show kind of the idea of, someone else is making an index and maintaining that, and I want to be able to get that data back into my application and work with it locally. So this is how you go about that. Any questions on the Python side? Right, then back to Matthew or Wesley.
Yeah, I'd say back to Matthew in that case.
Well, thank you, Wesley and Edward, for kind of sharing the latest. I believe both of these things went live
Yeah.
either yesterday or today, so you can start playing around with these things. We do have work in flight to create updates to our Learn site. Those should be landing hopefully within the next week or so. And then once those Learn content pieces are up, we'll then do a blog about it. So keep an eye out for the additional content. Alrighty, and then definitely give us feedback. We're a while away from Ignite, but we're hoping to solidify these APIs by then. Alrighty, so we have about 20 minutes left. So if there's any questions, feel free to raise your hand or drop them in the chat. I'm going to do a quick scan of the chat right now. Da, da, da. I think most of them were covered. Patrick is asking any updates on TypeScript. We still don't have any plans on our roadmap for TypeScript. If we do end up funding TypeScript, it would likely be after Ignite. So if you all want to do another check-in, I guess around the November, December timeframe, we'll probably be able to give some better visibility into TypeScript. That's a good question. And then Cyan asked any examples of Microsoft using Semantic Kernel for its own products. Excuse me. So there's kind of two ways to think about it. There's internal products that use it to power like their Copilot experiences. So the Bing experiences actually use Semantic Kernel to load in all of their different plugins or tools, or what are they called now? Copilot extensions. So that's kind of the broadest use. The Xbox experience, they have this chat experience. They also use Semantic Kernel, and that drives actually the most usage of Semantic Kernel within Microsoft. And then we have a lot of smaller teams that have started building AI applications, and Semantic Kernel's kind of been their best solution. So there's something called Partner Center, where independent software vendors, ISVs, can sell their wares through Microsoft. They have a chat experience that's powered by Semantic Kernel. We have an internal developer productivity team that uses Semantic Kernel. And one of my favorite stats, I'm gonna have to write this down, but they've saved like dozens of engineering years by basically creating these automated processes using plugins, using planners to basically automatically address and resolve bugs, right? So tons of folks internally using it, Microsoft, both for customer needs and for internal needs. And then we're also partnering with parts of Microsoft that provide developer tooling to leverage Semantic Kernel. So we've obviously worked with the PromptFlow team in the past, but most recently there's a team within Microsoft Industry Solutions. They're building a Copilot SDK that is built from the ground up on top of Semantic Kernel, and that's expected to land sometime around Ignite. Cool. Jose asks regarding the new multi-agent article, do you have a plan to integrate task agentic workflows? Yes. So if you read the article, there's a whole kind of section on kind of our strategy on multiple agents collaborating together. What we've seen from the market is that there's two different kind of approaches that you can take. One is, hey, we're going to shove everyone into a single group chat and they'll kind of collaborate and talk to each other. I like to think of that as like the autogen approach. And then there's this other approach that's being formed, and frankly, what most customers have developed independently, which is, oh, I have a business process of step one, two, three, etc. And at step one, maybe a human's uploading a file. Step two, I have an ingestion process. Step three, an agent's kind of reviewing it. And maybe there's a loop cycle, right? That is something that we're investigating right now, and we're hoping to at least have something preview-ish by the time Ignite rolls around. Jose.
Yes, I cannot just wait for Ignite. That sounds fantastic. By what I mean, it's for task-based, it's really, really exciting. So I've been exploring Creo AI, and if we can join these with a group chat or even nested chat and delegate tasks, that can be really powerful. Thanks.
Yeah. Yeah, so we're being inspired by Creo AI. One of the unique challenges that we're giving ourselves is we're imagining a future where if you're a Python dev and a C# dev, you can share these like durable assets that can kind of move around. And so what we want to be able to do with any of these task-based workflows is you should be able to define them in some sort of serialized format, whether it's a JSON payload or YAML, doesn't really matter. We should be able to define this thing so that as a researcher in Python, you can create this, run evaluations, make sure that it actually works before passing it off to your C# counterpart. So that's what's taking a while. It's a bit different than kind of our group chat experience where we just kind of copy pasted from AutoGen. We're actually creating something a little bit brand new. Okay. Jose, is that new hand raise or is that leftover?
It's a new one. Basically, I'm a bit against serialized format. I know that you use serialized because you want to deploy to AI Studio and other similars, right? So this is convenient. But unless there's a way to, when you are building your applications, to have a compile time check on the serialized, but usually everybody's having issues there. Because of one character, one thing, unless you have it ready, but somebody modifies it, adds a character, a wrong character somewhere, and then everything on the application is screwed up. So that's just my feedback.
Yeah, and I guess my expectation for most of these things is that these are assets that are checked into GitHub, so they should have tests run on them. There should be integration tests. Um, in that sense, they shouldn't be much different than a coding file. Hey, if I add an improper character, there should be tests that catch it. I do like the idea of maybe not compile time checks, but in VS Code, red squigglies, and other checks that we can do to make sure it's less error prone for the developer. Okay. Jeffrey asked, will there be prompty support for agents? Work on an upcoming with some internal documentation. Guidance on how to manage prompts, and prompty is something we're looking at. Since it's the build, I haven't seen it used a whole lot in semantic kernel examples. So curious if this is something, et cetera, et cetera, et cetera. So the kind of the most powerful templating language that we have, or templating system, is kind of using our YAML prompts. Yeah, you can use the prompt flash instructions, but I personally don't like it because it's like separate files. Our YAML format kind of collapses these things. The reason why is it is tied a little bit more closer to semantic kernel, and you can inject in things like kernel functions and some more complex arguments using like handlebars and stuff. If you do not need to use kernel functions and you're just like injecting in variables, you can of course use prompty. I am not aware of if they are planning on supporting agents that's coming from another part of Microsoft in Azure AI platform. So I can follow up with them and see what their plans are. Tristan asks, and then once this question's over, Luke, I'll get to you. Oh, great. Here's a question. Is that vector story? Okay, that's just a follow-up. Yes, there should be tests. Okay, Luca, you have your hand raised.
Yeah, I have a question, Matthew, which is not strictly related to the semantic kernel, but I would like to have a feedback from you and the team based on your experience. I am thinking to migrate my, let's say, semantic kernel chat completion implementation to the assistant APIs implementation. Beside the additional capability that assistant APIs provide, do you have any feedback about the performance quality, or should I expect any change from the basic, of course, use cases? So by implementing a chat completion using the assistant API, should behave in a very similar way in terms of quality and in particular performance, or should I expect something different?
Behind the scenes, it's doing pretty much anything that you would do with Semantic Kernel, which it has a little loop where the AI gets a request, decides to call a bunch of tools, then finally responds back to the user. So like there isn't too much extra work going on there that would, I would say, cause latency. So like from a performance and reliability and all that good stuff, I wouldn't expect anything different. The main reason you'd want to use something like assistance is, of course, it comes with these cool tools like the code interpreter and the file retrieval. You could build these yourselves. These could be plugins. In fact, we provide guidance on how to build your own custom code interpreter with Azure Container Apps dynamic sessions. But basically, if you use assistance, it's like, I don't have to worry about that. I just use it. To me, though, the best value is how it manages threads. And this is where you might see some difference in behavior. So if you stood them up side by side, they could start answering differently. And the reason being is in semantic kernel, or basically if you're just using chat completion, you have to manage the chat history yourself. In assistance, that's managed by the service, and it's a bit of a black box. It does really well, so it's a really good black box. But they do some like trimming. We suspect they do some like memory management on top of it to make sure that whenever your request happens, it just gets the payload that's required to answer that question.
Okay, clear. And final question, do you, I don't know if the assistant API implementation from Semantic Kernel already implements functionalities like filters or something like that that I used for the chat completion.
Great question. So if you're using the chat completion agent, filters will work. Because the assistance API is kind of that black box, it's doing that internal agent lifecycle inside of either Azure services or OpenAI services. So we frankly don't have control. And so that could be a reason why you want to use assistance versus semantic kernel. That being said, the one filter that does still work, I guess, is the I function invocation filter, because that's something that even with the assistance API, it pushes back to the client semantic kernel to do something with it. So you can still use that filter if you need to.
Yeah, that was the scenario that I had in mind. I mean, implementing my custom plugin and having the filter to intercept this call, but I'm used to use the auto function calling. So I don't know if instead, if I understood well, you were mentioning the filter for the manual function calling, or it should work also for the automatic?
So the automatic function calling filter, someone on the engineering team correct me, but I don't believe that works for assistance, because basically the service is doing that automatic loop itself. But the I function invocation filter, which is called whenever a function is called, should still work.
Okay.
And if it doesn't, file a bug on us.
Okay, thanks.
I'm getting a thumbs up from Dimitro, who basically owns them. So I must have gotten it right.
Thank you.
Okay. Glenn asks, is there a sample of using Semantic Kernel with the uploading of files? Yes, somewhere. I don't know if someone can beat me to it.
Yeah, they're
I
in
heard-
the concept samples. So not the getting started with agents.
Yeah, which folder is it in?
I can find it.
Oh, maybe it's agents. Ah, okay, I found it. Okay, so I'm going to drop a link in the chat. And there's a few samples that have file in the name that you can probably reference. Okay. And then Jose says, what's cool about Crew AI is the definition of done. So that's probably the thing that we love the most as well. And we've seen some internal research projects within Microsoft where they do something similar. Basically, for those that aren't familiar with Crew AI or for some of these other techniques, is when you work with AutoGen, the goal is just like you pass messages across, and that's how information is relayed between agents. If you think about more of a task workflow, you don't just like send a huge email of everything that you've done and include all of your tasks and documents inside of just a bunch of text and send it to someone. No, you typically create an artifact. Oh, here is my PowerPoint deck. Here is my Word file, or in like frontline industry, hey, here's my receipt. Here's my invoice. Here's my whatever it might be. Especially in the latter cases, you want that in some structured way so that when one agent creates that structure, it can be consumed in a reliable way by agent B or by another human, shown in some sort of UI. And so what we're working on is basically allowing you to create a prompt function that instead of just returning chat messages, actually returns structured output. Okay. So you might have a prompt that asks to generate an invoice. And inside of your prompt definition, you should be able to define, hey, I expect this output. This is the JSON schema of that invoice. And what we will then do as semantic kernel, similar to how we have like this automatic function calling loop, we'll have this automatic loop with the LLM until it's able to completely fill out this schema, this artifact, this definition of done, before we can then pass it off to additional steps. So that's what I'm most excited about. I haven't seen too many other SDKs except for maybe like Crew AI that have done this. And I think it's going to provide a ton of actual business value because what's productivity if not generating a bunch of artifacts for other people? Cool. Patrick asks, is Assistance API cheaper to run than the semantic kernel? That I don't know. Does anyone? I actually don't know what the pricing is for Assistance API. Evan, do you happen to know? Shocky.
Yeah, I think it's based on model calls still. It's a tricky question because one is a service where you get what you get. The other one you can, with semantic kernel, do whatever you need to do with, like we've been talking about, hooks, filters, memory providers. You don't get any of those options with the Assistance API. So it's kind of an apples to oranges comparison.
There's a question on being able to share the custom code interpreter. We have a nice little demo. I just pasted the link for that in the chat.
Yeah, I got those links, Matthew.
Oh, never mind. I was reading the next thing. I was like, oh no, Evan's already got it. So I'll delete mine. Cool. Let's do a quick time check. So we have 3 minutes, so we probably have time for one more question. Otherwise we can wrap it up here. Alrighty. Well, thank you, everyone. Cheers.
Thank you. Thank you.
Thank you.
Okay.